This recording is for Algebra 1, Chapter 4, Lesson 5 for direct variation. Direct variation functions in the form of y equals kx, where k does not equal 0, and that is a direct variation. The constant variation is k. K is the coefficient of x. So basically, you're going to have an equation where y equals kx, where k is a number. Now you can solve for k to figure out k if you have a y and an x, or you can use k to figure out different points on a line, obviously if it varies directly. If you can write it as a y equals kx, then you know that it does vary directly. All right, and so I've got some equations for you. So the first one is 7y equals 2x. So if I divide by 7 on both sides, divide by 7, I'm going to get y is equal to 2/7 x, which means it can be written as a direct variation, which means it does vary directly. All right, next we have that. So I'm gonna, I got to get y by itself basically. So we've got 3y is equal to negative 4x plus 8. Divide by 3, divide by 3. This ends up not varying directly because it has basically that going on. So that does not vary directly. And then for this equation, we're going to add 7.5x plus, 7.5x. Y equals 7.5x, which it does vary directly because it is in the format of y equals kx. That's a y, by the way. Y equals kx. Okay, next slide. All right, to write an equation for direct variation, use a point that is not the origin, can't use 0, 0, solve for k, then create an equation using k. So if we have the point -3, 6, and we know that it lies on a line that varies directly, or as directly varies, we can determine the equation of the line by first plugging in the -3 and the x and the 6 for y and x, and we're going to get y equals kx, which is 6 equals k times -3. And then, so that was step 1. Step 2 is solving for k. So we're going to divide by -3 on both sides and figure out that k equals -2. And to actually figure out the equation of the line, we're going to plug -2 back in to k, and that will be at that. So that's the final answer. So if they want you to determine the equation of the line, you do pretty much have to go through those 3 steps. Okay, next step. All right, word problem. A recipe for a dozen muffins calls for 1 cup of flour. The number of muffin varies directly with the amount of flour used. Write a direct variation for the relationship between the number of cups of flour and the number of muffins used, or number of muffins made. So if x is the cups of flour used, that is our independent variable. Basically, the number of cups of flour used in our muffin mix is then going to determine the number of muffins we make. Therefore, y is also the dependent variable. So if we go ahead and make an equation, we know that something's going on to the number of cups of flour to give us the number of muffins made. So this is basically our direct variation, y equals k times 1. 1 cup of flour, 12 muffins. So then we're going to solve for k. Divide by 1, divide by 1. K equals 12. And so if we plug it back into the equation, y equals 12 times x. So if I put in 2 cups of flour, 2 cups of flour, 2 times 12 is 24, so that means I'm going to get 24 muffins out. I don't think it works quite like that in baking, but yeah, there's other things going on as well, like cinnamon or bananas, if you like banana cinnamon muffins like myself. Okay, moving on. Alright, so y equals kx can be written as y divided by x equals k, because if you just solve for k, you're dividing by x. Makes sense? Alright, therefore you can determine if data varies directly if x and y form a constant ratio of y over x. So if I were to determine if these tables represent direct variation, I should be able to divide y by x each time and get the same number out because the ratio should be the same. So if I do y divided by x, I'm going to get negative 1.6. Y divided by x is going to give me 2.4 and then 0.4. So since these are not the same numbers, this is not a direct variation. Whereas for the other one on the right side, if I do y divided by x every time, I'm going to get 1.5 every time. Therefore, the direct variation is 1.5, and I can write my formula, or the direct variation of as y equals 1.5x. Okay, last slide. There it is. Okay, so for direct variation, the ratio y over x is the same for all pairs of data. So the proportion y1 over x1 is equal to y2 over x2, meaning you can rewrite a proportion as an equation of direct variation. Just create a proportion with the given information. So a windlass is kind of like a crank, and it allows you to lift things with less force. So if you're trying to lift a heavy thing, like say a 32-pound object, you're not going to have to use 30 pounds of force to lift it, or you actually need more than 32 pounds. The windlass will actually allow you to use less force to pick up a heavier item. So suppose a windlass requires 0.5 pounds of force to lift an object that weighs 32 pounds. How much force would you need to lift a 160-pound object? There we go. Okay, so let's go ahead and make a proportion. So pounds of force over weight of pound is equal to the pounds of force over the weight of pound. So we have 0.5 pounds of force lifting a 32-pound object. How many pounds of force would be needed to lift a 160-pound object? So I'm going to do cross product, and I'm going to get that formula, and I'm going to solve for x, and x equals 2.5 pounds of force. And if you need more information about a windlass, there's a little more on page 204, or you could also Google it. All right, I'm done, guys. Talk to you later. Bye.